Okay, good morning to all of you. So now we are starting our topic 3, methods of drug evaluation, in which chemical and physical methods of the drug evaluation. So here you are observing the good photograph of the crude drugs are there. So how the drugs are selected, particularly from the natural condition, how there is a processing is there. So the first as per our syllabus, so during the drying of the drugs, as it undergoes the unequal contractions and assumes the different shapes are there. So we are knowing our common example, there is the clove is there, cinnamon or the other drugs are there. So this shows the different types of the methods are there. So first one, organoleptic method is there. Organoleptic, that is the based on the external characters are there. So here you are knowing there are the good these examples. The first one photograph, it is of the cinnamon, right? So it shows the specific in the dry condition. Secondly, on the lower side, so cinnamon is a bark of the tree is there. So it shows there is the specific type of the drying methods are there, right? Then the secondly, you are observing from the lower side, the ginger is there. So in from the field when it is collected, or same thing the turmeric is there. So it is also natural one. So how the based on the storage of the roots or the storage of these conditions like rhizomes are there. So they are selected from the field, and there is a processing is there, removal of the soil, removal of the dirt material, and proper shade drying is there. Nextly, some leaf drugs are there. You are observing here senna leaves. In Marathi it is called as the sonamukhi. Then tulsi is there, osimum. So osimum sanctum is there, right? So it is also one of the medicinal use under the leaves drugs. And under the flower, here you are observing this is the saffron, केशर म्हणतो आपण त्याला. So generally based on the quality character, the female reproductive structure, the flowers from the flower, that is the carpel, it is to be selected, and it is a tedious job. Here you are observing this photograph where the stigma also or the carpel, these are going to separate from the flower, and it is used as a saffron or kesher. Then here good example, our almond is there, badam, and the amlai fruits are there. So the seeds of these and the fruits, they are also used for this one. So almond, it is to be selected from the fruits, and it is selected. So shape, size, structure, color, all these are the parameters for the organoleptic or the external character. The seeds removed from the ovals in the carpel. So here we are observing the examples like the anjir fruits are there, or you are observing the sesamum, right, javas. So as it is to be selected. Then good examples as there is having the terminalia cebula and the dry condition. So in fresh condition हिरडा म्हणतो आपण त्याला. So this terminalia, so it is called as a dry fruit, or it is the called as a myrobalan, right? Then so this is the first method, organoleptic. In the next one, as so based on these characteristics, so we have seen about the one method. Then second, physical methods are there. So in the physical methods, the firstly we have to go about the physical elasticity of in the fibers, viscosity of the for the liquid drug, then coagulating point of the volatile and the fixed oils, melting point, boiling point, then water content, and therefore these different parameters are used for this one. Nowadays ultraviolet light, it is also used for the fluorescence of the light is there. Then in physical condition, suppose such as other contents, alkaloids, volatile oils present in this one. So few of them, they also shows the moisture content, then viscosity, melting point. Viscosity means how is the structure? Suppose our normal we are using the oil which is not essential for the preparation. So if it is kept open in the air, so it shows the semi-solid structure and it is called as viscosity. Then optical rotation, refractive index, ash content, extractive value. Extractive, that is after extraction, what is the percentage of the contents are there. Then volatile oil content, right. Then in viscosity, as it is a liquid which is constant at a given temperature and is an index of its composition, right. So good example is the liquid paraffin, less than 64 centistrokes, it is to be having the measurement. Then moisture content, under moisture, the presence of moisture in a crude drug can lead to the deterioration, and therefore due to the either activation of certain enzymes or the growth of the microbes are there, right. Then moisture content can be determined by the heating the drug at a 150 degree Celsius in the oven to a constant weight and the calculating the loss of the weight. So based on this, it is to be calculated. So it is called as a moisture percentage. Then melting point, it is one of the parameter to judge the purity of the crude drug. The purity of the crude drug can be ascertained by determining their melting point in the range shown against each of them. So it is to be done at the, for example, cocoa butter at 30 degree to 33 degree Celsius. Then optical rotation. So many substances of biological origin have a chiral center and can rotate the plane of polarized light either to right or to the left. We are knowing this optical rotation is generally done from the prism. So the extent of rotation is expressed in the degree. If it is plus, indicating the rotation to the right, and if it is minus, then indication rotation is in the left side. So like this one, this optical rotation, it is to be calculated. Such compounds are optically active and hence called as the optical rotation. So this is a parameter is also used for the evaluation. Then refractive index, when a ray of light passes from one medium to the another medium of the different density, it is bent from the original path and it is measured by means of refractometer. Good example, RHS oil, that is our groundnut oil is there. So it's having a refractive index 1.4678 to 1.4698. So 0.020 content, it is having the angle. So we are knowing there are the prisms are there. So these prisms are used. Then nextly there is the use of the ash content is there, right. So ash that is after burning. So what is it? The residue remaining after incineration of a known quantity of the air dried crude drug is known as the ash content of the drug. The ash is simply represent the inorganic salts naturally occurring in the drug or adhering to the to it or the deliberately added. For example, Ashoka bark is there. So after burning it shows 11 bar. Then ginger it shows the 6. So you see this is a good photograph. Then extractive value. In the crude drugs, sometimes the active chemical constituent cannot be determined by normal procedures, and therefore in such cases water, alcohol or the ether soluble extractive values are determined. So the dissolution into this one, water, alcohol or the either ether, it is to be calculated. So water soluble extracts like aloe vera, alcohol soluble like the ginger. So this is the one part is there. Then volatile oil. This volatile oil, some of the crude drugs are the standardized on the basis of their volatile oil content. They are when quantity of the drug is boiled with the water in a round bottomed flask fitted with the cleavanger apparatus. So here you are observing the proper distillation method. It is to be separated from this. So you see this is the distillation unit. Condenser is there or the collection of the volatile oil is there. So after proper technique, I think we have started for the some points here. Then RF value. So by chromatographic technique, it is used for the qualitative and the quantitative evaluation of the drug. So this RF value refers to the rotation of distance traveled by the solid to the distance moved by the solvent on a thin layer adsorbent. So chromatography we are knowing there is the having the specifically as it shows shows the character as the separation of this solvent distance of the solvent travel 5 centimeter, and here you are observing distance sample traveled by the it is 2.5 centimeter. So new position of the sample is there. Then so all these are the physical evaluation methods. Then next one, chemical evaluation. So determination of the active constituents in a drug by chemical test is referred as a chemical evaluation. So there are instrumental method, chemical, individual chemical test and the microchemical. In instrumental we are using different instruments like colorimetry, fluorometry, spectrophotometry. And in chemical constant, the values like the acid value, iodine value, ester value are used for the identification of fixed oil and the fats. In individual chemical, there are the test used for the identifying particular drugs. For example, Helper's test for cotton seed oil. Then microchemical, there are 3 tests carried. One is the eugenol in the clove oil is precipitated as a potassium eugenate crystals. So these are the 2 common. Then in chemical, the determination of active constituents present in the crude drugs. So following different methods: instrumental, chemical, individual and microchemical. Already in instruments we have seen these methods: colorimetry, fluorometry, then chemical methods, then individual chemical and this one. So in chemical method, extracts obtained by taken by using the petroleum ether, chloroform, ethanol or the water as was prepared using the respective solvent. These extracts along with the positive and negative controls were tested for the presence of active phytochemical as for example tannins, alkaloids, phytosterol, triterpenoids, flavonoids, cardiac glycosides, anthraquinones are there, then glycosides, saponins, carbohydrates, proteins, amino acids, fixed oils, and the fats. For tannins, ferric chloride test. It is used for the 5% ferric chloride solution to 2 ml test, and it shows the end point as there is having the presence of hydrogeable tannins are there. Blue coloration is there. Then in gelatin test, 1% gelatin, 10% sodium chloride to 1 ml test, and it gives the white precipitate. Alkaloids are there. Approximately 50 mg of extract was dissolved in 5 ml of distilled water. Therefore, the 2m hydrochloric acid is added, and it shows the reaction. So, presence of alkaloids as detail. The different reagents are used. Drag drop reagent. 2 ml of this used in filtrate. Added 1 ml reagent, and it shows the orange red PPT. Then Mayer's reagent, 1 ml of test solution, 1 drop of the Mayer's reagent, it shows creamy precipitate. Then Hager's reagent, 1 ml test solution plus it shows a drop, it shows yellow PPT, and it is positive, that is presence. And Wagner's reagent, 1 ml test solution, and it shows the brown PPT. So like this all tests are used. Then in the Phytosterols test, so Ligerman Burkhardt test is there. So extract 2 mg dissolved in 2 ml acetic anhydride, heated to boiling, cooled, and then 1 ml concentrated H2SO4 is added. So it shows the brown ring is seen at the base. Then there is the triterpenoids are there. So approximately 2 ml Salkowski test shaken with the 1 ml chloroform and few drops of the concentrated sulfuric acid. So like this it is to be used. Then flavonoids are there. So it is in the Shinoda test for flavonoid. Magnesium, a few magnesium turnings are there. 5 drops of concentrated H2SO4, then 1 ml of test solution, and it shows the pink color. So it shows the presence. Then alkaline reagent test, 5 drops, 5% sodium hydroxide. It shows the yellow coloration. Then saponins are there. Saponin, that is soap formation, right, process. So here the 5 ml solution shaken for 5 minutes, and if it is showing the formation of stable foam formation, it is the mechanical test. Then olive oil test for saponin. So few drops of olive oil to 2 ml test solution, and it gives the, which shows the soluble emulsion conformation. If it is soluble, there is no soap formation. Then Kelker-Kulkarni test. It is used for cardiac glycosides. So 0.4 ml of glacial acetic acid and drops of 5 ferric chloride solution. So further it shows 0.5 ml of concentrated H2SO4. The formation of the this positive color change, so it shows the positive. Then for test for carbohydrate or carbohydrate, so common Molish test. So few drops, 1% alpha naphthol and 2 to 3% H2SO4. The reddish violet PPT. So it shows the, then Barford test. So 2 ml test reagent, 2 ml test solution kept in boiling in the water bath for 1 minute, and red PPT is formed. Then Selene Ops test. So the reagent, 1 ml test solution, 3 ml reagent, and the kept in boiling heated water bath, the formation of rose red coloration. Like this filling solution is there, right. So all these tests are there. Anthraquinone glycosides are there. So it is tested by the biurate. So you can remember any one test from this one. Test for proteins, commonly 1% copper sulfate is used, biurate test. And then the test for the amino acids are there. So all these tests are there. Fats and the fixed oils are there. So 5 drops of sample, 1 ml of this solution is there. So I think you remember all these tests as a evaluation of the crude drugs are there. Okay, so thanks to all, have a nice day.